So to make our fuel, we have to utilize some potassium nitrate that can be found in stump remover and ordinary powdered sugar. And to do that, you just mix up the 65 grams of potassium nitrate in a blender. And here we got some catalytic for the end plugs. And then add in 35 grams of ordinary powdered sugar. You don't want to put that in the blender though, because at that point it is very flammable, so you just got to mix that by hand. And then got your own rocket fuel.
So this is the fuel we're using for our rockets. It's a little bit of potassium nitrate and powdered sugar, and we're gonna burn some.
Commencing countdown, engines on.
Oh
Check
yeah.
ignition and may God's love be with you.
It shattered the glass.
This is ground control to Major.
Alright, so the main key to getting a stable rocket flight is to make sure that your center of gravity is in front of your center of pressure. And how we did this is we found the balance point of the rocket, and then we tied a string around that point, and we'll spin it around in a circle and see if it flies straight, and if not, you can either add more area to the fins in the back to move the center of pressure backwards, or add more weight in the front to move the center of gravity forwards until you get it just right.
And I'm floating in the most peculiar way, and the stars look very different today. For here am I sitting in a tin can, far above the world. Planet Earth is blue, and there's nothing I can do.
So today we have a different kind of motor. This is a 1-inch diameter, a 1/4-inch diameter more than our ordinary motors, and we decided to make it about an inch longer. So it's in total has about 2 times the fuel. We're gonna see what happens.
Though I'm past 100,000 miles, I'm feeling very scared, and I think my spaceship knows which way to go. Tell my wife I love her very much. She knows. Ground control to Major Tom, your circuit's dead. There's something wrong. Can you hear me, Major Tom?
So our new bigger motors seem to keep blowing up on us. As you can see here, this one completely shattered. These are rated to 240 pounds of pressure, and it's still exceeding that. So we're gonna try drilling a bigger hole, hopefully allowing the fuel to come out faster and not build as much pressure. So we'll see if it works.
Planet Earth is blue, and there's nothing I can do.
So that time the motor didn't blow up. We kept both of our end caps in, but once it landed, it split the whole tube and melted it. It's a little bit of a problem in a rocket. Oh no!
Oh my god. It's coming down hard. Holy crap. Just found the first rocket that actually worked. It landed a little hard.
It's okay though.
So after our first test, We had to cut off the front of the rocket since it got completely destroyed when it hit the ground. But in order to keep our center of gravity in front of our center of pressure, as we talked about, we put a bunch of dirt in the nose cone to hopefully balance it out, and we'll see if this works. Against better judgment, we decided to launch the rocket tonight, despite the fact that most of our motors have not worked. Here we go. Yeah, baby!
So here we have a little bit of what looks like to be molten clay or some of the fuel that we used. Burned so hot.
Alright, so we're gonna try one more motor. This time we have a slightly smaller hole, because last time it did not provide enough thrust. And at the moment we're just hoping it's not gonna blow up inside the rocket, so we'll give it a try. And in the bigger rocket, we made one of the motors that we know consistently works. And we made a few spacers to make it a little wider so that it fits into the mount we have in this rocket. So when you put it in, it fits in there perfectly, and hopefully it'll have enough power to take off. Oh no! You might not want to breathe that in too much. Okay.
Not enough power from this motor.
Alright, so we found a few various parts of different rockets and taped them together to make this bad boy. After a few minutes of drilling, we got a smaller motor to fit in the end. Hopefully it won't be overpowered for this rocket, and we'll see if it works.
Oh yeah!
So after using the third kinematic equation to find how high our rocket went, using the average time from the apogee to the ground of 10.2 seconds for the motor, we found that on average the motors were going around 509.8 meters, which is equivalent to 1,672 feet. Alright, using that same kinematic equation, we found the height of each of the three rockets we tested. The first one, which used 3/4 inch PVC, we found had an average time from apogee until the ground of 11 seconds, giving us an average height of 1,945.21 feet. Now the second rocket, which used the 1-inch PVC engines, the big one, we found that the best we could get out of it was 36.17 feet off the ground. Surprisingly, our little one with the 1/2-inch PVC had a time of 12.4 seconds from apogee until the ground, giving us a height of 2,471.78 feet. Alright, so just for fun, we put together a giant motor. We had some trouble getting this one to stay with the clay ends, so we ended up using a little bit of Play-Doh to hold it all together. It contains about 6 times the amount of fuel that we had in our other rockets, so we're predicting it's just gonna blow up, but we'll see what happens.
Oh my gosh! Look at all the smoke!